Then Dr. Vijit Meshram, sir.
Yes, ma'am.
Vandana Singru, ma'am. Vandana, madam, are you there? वो है लेकिन कोई और कुछ काम कर रहे होंगे इम्पोर्टेंट दैन दिस रिफ्रेशर। भरत सर का तो हो गया है, भरत मडावी सर। डॉक्टर गहाणे सर, आपका भी हो गया है। तो डॉक्टर पी प्रेमचंदर सर, तो 3 ही सेमिनार्स अभी बाकी है अपने। डॉक्टर विजित मेश्राम सर,
यस मैम।
आप प्रेजेंट करेंगे?
हाँ मैम, मैं प्रेजेंट
जी
करूंगा।
जी। विजित सर, आपने मोबाइल से ज्वाइन किया है?
मैम एक्चुअली टैबलेट से है
हाँ,
तो।
मतलब आप कर पाएंगे ना, कोई प्रॉब्लम
हाँ हाँ,
नहीं ना?
कर पाऊंगा।
जी
यस
जी।
यस मैम, हाँ।
ओके, जस्ट यू ट्राई टू शेयर।
ओके मैम।
यस सर।
ठीक है
It
मैम,
is,
इज इट
yeah,
विजिबल?
yeah, yes, it is visible. You can start.
Okay. Okay. Thank you so much, ma'am. Very good afternoon to Dr. Priti ma'am and all my fellow colleagues. My name is Vijit Mishram and I'm working at the PG Department of Computer Science in Ambedkar College, Diksha. So my today's topic is like a prequel to Tirumurti sir's topic of 5G, as this technology of VoLTE is currently ongoing technology in the market, and nearly everybody having a smartphone is using it. 5G has started spreading in the market right now, and even in India, it has been launched in 13 cities and slowly expanding its footprint all over India. And we all people will be migrating from 4G to 4G VoLTE mainly to 5G in coming days. But basically, we just wanted to know that how the technology changed from 3G to 4G and from 4G to VoLTE. That's why I'm presenting this topic. So the world has changed a lot in the last 20 years, but there were few things which hadn't changed at all. There was no change in the life of voice calls until this VoLTE was launched. It was the same voice call on 2G earlier, which continued on 3G without any major changes for so many years. Nowadays, we can make crystal clear HD calls on our phones with the help of VoLTE. This is also called as voice over, that is, the VO is the voice over, and the LTE network, which is the long term evolution network. Today, I'm going to explain to you some technical aspects of voice over LTE technology. So VoLTE stands for Voice over LTE or 4G network for easy understanding. It's ordinary voice calls which is carried over data network. This works like normal cellular calls and charged on the same rate with no extra money required. Since this call is carried over IP networks provided by the 4G, it also gives us a lot of flexibility and also to the mobile operators to enhance voice calls here. For example, if we are using a high-end smartphone, many of us might have seen that whenever we are calling, we might get an HD symbol on the top of our calls that is used, that shows that you are using a 4G VoLTE network and you are getting better codecs and better visuals. So moving forward, so let's understand how VoLTE works. For understanding VoLTE, we need to go back into the history where VoLTE was not launched, as there was only 4G network along with 2G and 3G networks. Networks working on the as we discussed, 4G came prior to VoLTE. 4G started getting commercial launched in 2009, which VoLTE came very late, around 2014 or so in India. Since 4G is an all IP to IP technology, therefore it cannot transport circuit switches such as voice calls. You can see on the screen that so many data packets are now moving between internet and the user, like from here to here, and that's why uh, yeah, between the internet and the user. These all people are using the 4G network. Now, here comes the use of VoLTE networks, where in a VoLTE network, circuit switching was not used, and uh, user is just basically when we are using a 4G network, the user is thrown for a voice call to a 2G or 3G network which is underlying below it, and that's why it was a problem for the 4G network to carry voice call as well as the internet to provide both the things. While user was able to circuit switch for voice services, but there was so many problems with this technology as user needed to switch between a 4G network, and again while calling he needed to switch to the 2G or 3G network, and this also required a lot of battery in the handset and also generated a lot of signal traffics for mobile operators. This was really bad for the network. So everyone started to work on a better solution, and they came up with a VoLTE as a solution of all these problems. So let's understand how this VoLTE works. So VLTE uses 4G data connectivity to send data packets for voice calls. Even for voice calls, it uses data packets. Basically, it's like calling someone using internet, just like WhatsApp call or Skype call. VoLTE enables the voice on LTE networks on 4G networks. Let's understand how VoLTE works. As LTE have given us all IP to IP based network, we need to have some technology to carry voice traffic using IP packets over data connection. For this, VoLTE solution was discovered. We also call this as packet switch network, as all traffic goes in form of streams or IP packets, and it does not require dedicated or reserved path. So we have some benefits of using VoLTE. The first benefit is better user experience. As user is not running pillar to post between 4G and 3G radios, this improves overall experience of user, and it also brings a lot of relief for mobile operators. The second benefit is HD calling. Now, as VoLTE is running on all IP to IP based packet networks, this provides opportunity for mobile operators to use bigger pipes or bigger broadbands or bigger codecs for carrying high definition video calls. This gives us crystal clear HD voice calls on VoLTE, which was not possible on old 2G or 3G networks. The third benefit is no drop in background data speeds. So as discussed in the previous slide, we can see that whenever internet was connected, the call quality, or even when a call was connected, the internet quality was decreased at some level. Now in this technology, when we are using 4G, no drop in background data speeds is seen over here. So another great benefit of this is faster calling. A VoLTE network connects calls faster than any legacy network. A normal 3G call takes around 4 to 6 seconds, but VoLTE call requires less than 1 second to connect. Now, as it is not moving between 2G, 3G networks, it also gives a better battery life. So since our phone is not changing networks from 4G to 3G to 2G for voice calls, it saves a couple of battery life for us. So now let's quickly understand the evolution of mobile technology and the history of VoLTE. Initially, IMS network, which is the core network providing VoLTE services, was opposed by various operators due to multiple complexities involved in this. In the year 2009, a couple of operators and equipment manufacturers such as AT&T, Verizon Wireless, Nokia, and all such people gathered over and proposed a solution for IMS-based VoLTE network. This initiative was called as One Voice, and the proposed solution was supposed to provide seamless and common solution for voice over IP networks. Now, you can see a timeline over here where we can see that when was 2G launched, then 2.5G was launched. If we go to some like 10, 15 years ago, we were using 3G technology, and now everyone uses 4G technology. And even further, if we see in our handsets, there will be written VoLTE, which is voice over LTE network. So this is a short slide, I would say, that how we can enable VoLTE in our handsets. So there are basically two types of handsets which everyone use, either Android based or iPhone, which is iOS based. So in the settings, we can search for VoLTE networks or LTE networks, in which you can see on the left side that if you are using an Android phone, we can see for this enhanced 4G LTE mode, this function would be available in your settings. And if you're using an iPhone, even there you can see it is not mentioned in this picture, but yes, you can search over here in the settings, and you can see that 4G networks will be available over there. Now let's see what are the requirements for VoLTE service. Usually every mobile operator performs testing of a handset, and then handset manufacturer such as Apple, Samsung, etc. These people enable VoLTE support in software build shipped along with the handset. this software build and operator will decide whether VoLTE will work on your handset or not. So that's why in some phones it is by default activated, and in some phones you have to activate it. Here we are going to cover the mandatory things required for VoLTE to run. On left hand side, we can see stuff which needs to be done by the mobile app operator, and on the right side, we can see stuff that is to be done by the customer. So let's start with the mobile operator first. The first thing for mobile operators is good 4G coverage. A good 4G coverage ensures users can make or receive calls fluently. So that is why this is the most important thing that needs to be done by the mobile operator. And the second thing is provisioning of VoLTE services. Your mobile operator needs to activate or provision VoLTE services in the profile of the user. And that's why activation of VoLTE services by the mobile operator is also important. Now, what has to be done by the customer? The customer has to activate or at least buy a VoLTE supporting handset, which most of the handsets nowadays are there supporting VoLTE. Then second, he needs a iSIM or a USIM which supports 4G networks. Like when we'll be migrating to 5G technologies, we'll be forced, or we would need to buy a SIM which is compatible for 5G. So that's why also there should be a VoLTE switch enabled in the handset. Suppose you want to save your battery or data, you can switch the VoLTE on and off over there. So now let's see what all benefits VoLTE brings to mobile operators. The first one is the increased spectrum efficiency, where operators have wasted a lot of spectrum on older technologies such as 2G and 3G. If we can reuse this 2G spectrum or 3G spectrum and refarm it to LTE, by doing this, operators will be able to use precious spectrum in a better way. Operators can do this once majority of customers are moved to VoLTE networks, which I think nowadays many of the customers have been migrated to VoLTE. The second one is the voice is still a business driver. So basically, most of the people use mobiles for voice calling, and internet surfing and these things are secondary. But why someone buys a mobile? That is to use it as a primarily as a voice calling device. So even in 2022, voice is still accounted for approximately 50% of the total revenues coming from mobile operators. Providing better voice experience is now mandatory for all mobile operators in order to survive. VoLTE is the best way to cater to this voice requirements. The last one, I would say, is new service integration. So VoLTE enables faster, quicker integration of new services such as chat, multimedia services to compete with the OTT players in the better way. Now let's go through some VoLTE challenges. So majorly all majorly all operators today support VoLTE, but at some point of time it was a challenge as everyone was not agreeing to switch to VoLTE. As of today also, 5G has been launched by 2-3 operators and it's like running in 13-14 cities. At the starting point of anything, it's like a challenge to convince all the people to get into that thing. So the first one is not all operators support VoLTE. VoLTE is the second, I would say that not all handsets also support VoLTE, because when you're buying a handset, you have to see whether the handset supports VoLTE or not. The next one is increased complexity. As VoLTE increases complexity multifold, as there are many new nodes which generate a lot of signaling traffic. And then I would say that I would just sum it up. And these are some of the challenges which are in front of you. I think I'm running out of time, that's why. So how to handle network congestion in VoLTE? Have you ever thought that what will happen to VoLTE voice calls if radio is congested and means many people are calling at the same time? As a general principle, data internet can wait for some time, but voice calls cannot. Voice has to be real time. So VoLTE technology uses quality of service concepts used in 4G networks. This quality of service provides highest priority to voice traffic and therefore facilitates superhighway for voice packets to pass through in order to give the highest priority to voice. And that's how I would say that 4G technology with VoLTE works. So thank you so much. Thank you, ma'am.
Thank you, Dr. Vijit sir. Very nice. Good.
Thank you.
Next and the second last participant, Dr. Vandana madam, are you there?
Yes, madam, I am there. Sir,
Yeah.
madam, I share my PPT.
Yes, just a
Will
minute.
share my.
Yes, you please try to share.
मैडम शेयर हो रही क्या?
Yes, madam. It is visible. Kindly make it slideshow.
हाँ, yes मैम. ठीक है.
Yes, yes. You can
हाँ.
start.
Good afternoon to all. I would like to express my warm welcome to all distinguished dignitaries and participants in the seminar. I am Dr. Vandana Singru, Assistant Professor in Physics Department of Tai Golwalkar Mahavidyalaya here. So now from few days we are joined to online these refresher course quickly on 11 a.m. This is possible because of the optical fiber network in your house. So today my topic is the optical fiber and optical fiber communication system. So these are the contents of my presentation. Then here we will discuss what you mean by optical fiber. So optical fiber is a flexible transparent fiber which is made up of glass or plastic of diameter slightly thicker than human hair. So this optical fiber, so in optical fiber here the information carried by the light waves should need a guiding medium through which it can be transmitted safely. The guiding medium is called as the optical fiber. So in optical fiber communication system, here we use a light waves. So you know that the light waves are the electromagnetic waves, and these electromagnetic waves are required for the communication system. So here we use in optical fiber communication system, we use a optical fiber for transmit the information from one place to another place. And this optical fiber communication, it is very advantageous to us because it has immense bandwidth to utilize. Here there is a total isolation of there is a total electrical isolation, and it has very low transmission loss, small size, lightweight, high signal security, very low power consumption, and wide scope of system expansion. So here we are using the optical fiber communication. So here the optical fiber is an optical transmission device, works on the principle of total internal reflection. Now when light signal is directed from one end to another end of the fiber at the suitable angle, it undergoes the repeated total internal reflection along the length of fiber and finally comes out at the end. So here the working principle of the optical fiber, that is it is depends on the total internal reflection. Now what do you mean by total internal reflection? Here when the light rays are transmit or as incident from, or it moves from denser medium to rarer medium. So when light ray travels from denser to rarer medium such that the angle of incidence is greater than the critical angle, the ray reflect back into the same medium. This phenomena is called total internal reflection. So the light rays are incident into the fiber, and this moves in this zigzag manner from one place to another place. So here the construction, uh, how the optical fiber is constructed. So here the optical fiber consists of core, cladding, buffer and jacket. Here core is of diameter 8 micrometer, and it is made up of glass or plastic, and which have having very higher refractive index, and it carries the signal. Now cladding, so this cladding is having diameter 125 micrometer, and it is made up of glass or plastic having the lower refractive index than the core. So here the refractive index of core is greater than refractive index of cladding, and these coaxial cables are or here the buffer, it protects the fiber from the damage and moisture, and then jacket, it holds one or more fiber in the cable. So this is all about the construction of optical fiber. So there are different types of optical fiber which is based on material use, mode of transmission, and refractive index profile. So here as material use, there are two types, that is glass fiber and plastic fiber. Mode of transmission, there is a single mode optical fiber and multi-mode optical fiber. In single mode optical fiber, only one light rays can pass through it, and in multi-mode there are many light rays are passing through the multi-mode optical fiber. On refractive index, there is a step index and graded index optical fiber. Now on the basis of this refractive index, there are two types of optical fiber, that is step index optical fiber and graded index optical fiber. So in step index optical fiber, here the refractive index of the uh, cladding to core is increases steeply. So here the refractive index is increases steeply. So therefore we get such type of signal. This is a input signal and this is a output signal. Okay. Now then this is a graded index fiber. So in graded index fiber, the refractive index of this cladding is increases to a core gradually, and therefore we get such type of signal, and this is single mode optical fiber. Now here single mode step index optical fiber. Single mode step index optical fiber it has a core diameter of 8 to 9 microns, which only allows one light path or mode. Single mode fiber have a lower signal loss and higher information capacity or bandwidth than the multimode fiber. Now here this multimode step index fiber. So multimode fiber has a core diameter 50 to 100 microns, and it allows a several paths like this. This causes modal dispersion. Some modes take longer to pass throughout the fiber than the others because they travel a longer distance. So this is a modal dispersion. So when light is passed from one place to another place, at the end of the mm, fiber, we get such type of signal. So that is called the modal dispersion. And multimode graded index fiber, the index of refraction gradually changes across the core, and modes that travel further also move faster, and this reduces the modal dispersion, so the bandwidth is greatly increased. Now here there is some specifications of fiber optics. So there is a first is attenuation. Attenuation is, it is a loss of signal. This loss of signal is because of absorption losses, scattering losses, and bending losses, and it is measured in dB. Dispersion, blurring of the signal, which affects the bandwidth. Bandwidth is the number of bits per second that can be sent throughout the data link. And then numerical aperture. The numerical aperture is the measure of largest angle of light that can be accepted to the core. Now here numerical aperture, it is the we have discussed it is in detail. So here this is a cone of light acceptance cone. Now it is a measurement of the ability of optical fiber to capture the light. It describes the cone of light accepted in the fiber or existing the fiber. The numerical aperture is a sign of the half acceptance angle. So therefore the numerical acceptance in A, this is equal to sine of theta A. Now this theta A is the acceptance angle. Now what is this acceptance angle? So you know that here this is the light is incident into the optical fiber. So here mu 0 is the refractive index of air, and mu1 is the refractive index of core and mu2 is the refractive index of cladding. So according to Snell's law, this mu0 sin I, now here light is moving from rarer medium to denser medium, so here mu0 sin I is equal to mu1 sin phi. So here this phi angle, this phi is the 90 minus theta. So mu0 sin I is equal to mu1 into sin of 90 minus theta. So mu0 sin I is equal to mu1 cos of theta, and mu0 sin I is equal to mu1 into under root of 1 minus sin square theta. So here, as the angle of incidence increases, the phi also increases, but theta is decreases. So there is a maximum value of I beyond which the light ray entering the fiber, which fall on the core cladding interface at an angle less than theta c. So that angle is called the critical angle, and such a ray will refracted into the cladding and not will not propagate. So this maximum value of I, that is called the acceptance angle of the fiber, and this is the derivation for this, and we get the value of acceptance angle, that is I sin of I maximum is equal to under root of mu1 square minus mu2 square. So here the acceptance angles is depends on the refractive index of core and cladding. So here the here this is all about this. Now we are discussing the general overview of the optical fiber communication system. Now here this block diagram shows the transmitter receiver system. So here at the transmitter level there is a signal containing the information, that is voice, data, video from the source to the destination. So here transmitter transmits the signal, or it modulates and transmit the signal, and at the optical at the end at the receiver end we get the output signal by demodulating it. Now here we are discussing what is the transmitter in the optical fiber communication. So here this is the block diagram of transmitter. So here is the processor. So this processor increases the strength of the signal, which is in the analog form or it is in the digital form. So here the transmitter is an optical fiber communication system, has a processor that takes the input signal from the source device and made it ready to supply to the light transmitter circuit. Generally here light transmitter circuit, these are the LED, that is light emitting diodes, or the infrared light emitting diode, or laser diodes. So here this processor strengthen the signal input signal, and this is this is electrical signal, and that will be converted into light signal, and this is passed through the optical fiber. So the here this is the working of the transmitter circuit. Here there is a regenerator system. So regenerator system is used for a long distance data transmission. It helps a lot in long distance data transmission. The strength of the signal decreases, so basically the main function of this regenerator circuit is to make the signal stronger. So therefore the here there is a light detector circuit which detects the light, and it is amplified further, and then also it is converted into light electrical signal, and it is given again to the light emitter and transmitter circuit. So regenerator circuit increases the strength of the signal. Then here the receiver in optical fiber communication. The main function of receiver circuit, it is receive the signal from the light form of light. यहाँ से ये जो optical fibers है so it is fed the light detector circuit. So here there is a light detector circuit. Here the above block you can see there are the three blocks. The light detector circuit is made up of semiconductor device such as photoconductor or photodiodes or photo transistor. This signal is amplified by the amplifier circuit, and the sharper circuit mainly used to remove the unwanted noise. Here there is a sharper circuit which is used to remove the unwanted noise from the signal. Then it is demodulate and prepare it to send the destination devices. The whole optical fiber system works with the digital electronic signal because it provides high efficiency, easy modulation, demodulation, much more information transmission. If there are analog devices in the source and destination, at the first the analog signal is converted into digital signal at the sender side, and again the digital signal is converted into analog signal. So there are there are some applications of the optical fiber in telecommunication field. It is very much we are discussed already in civil, consumer or industrial application, in military application, broadband application, and in decorations is also used. And in endoscopy, in medical field, in endoscope, here there are two optical fibers are in endoscope. One for light to illuminate inside the patient, and another for camera to send the image back to the doctor. So I am completing this. Thank you, madam. Thank you.
Thank you, madam. Next and the last participant, Premchandar sir.
Yes, madam. Yes, madam.
Yes. Are you going to share
Yeah,
your screen or
yeah.
should I share?
Yeah, please, madam. Please, madam.
Yeah. Mama, तिथे ठेवून दे ना दोन खुर्चीला. नाही त्याला जाय. Yes, sir. Can you see the PPT?
Yes, madam.
Yes. Sir, there are 35 slides. So be
Actually,
faster.
yeah.
Yes.
Yeah. Just I'm telling about the applications only. I'm not
Yes.
very in depth of
Yes, sir. Please start.
Good evening, everybody. Good evening, everybody. So I would like to thank Dr. Preeti Garmit for coordinating such a wonderful online reference course. Will start. These are just, I think we are all faculty, so everybody knows that the basic what is MEMS and what is NEMS. These are all very basic things. But every day, day by day, and the technology is very improved, and this technology is really very useful for to create the tiny IC fabrication, the IC devices. It combines mechanical, electrical, and various other components to make the motors or some other things. I will just highlight only the applications, not for going all deep level things. So just in the contents of the talk is just introduce about the microelectron mechanical system, and then how the micron to nano, how the devices are going on like that. And in this case, I think what are the materials are involved in this talk. That is very important because the carbon, diamond, and these are all the micromeasurement materials. These are very much useful, and I will highlight only carbon here for the MEMS and NEMS devices. And here we have to focus on the high aspect ratio and how the according to the high aspect ratio, how the devices improve, and the surface area and how it is very well focused, and also 2 or 3 3 level carbon MEMS are available. And what are the suspended structures, and maybe suspended structures means which effective structures are present like that, and self-assembled carbon microelectromechanical systems. And majorly I will focus on the applications. Madam, next. It's a interdisciplinary nature of the MEMS. It involves design actually. There's many software techniques are there for modeling, and it is very essential for a microelectronic mechanical system because we could not able to fabricate in the device fabrication whatever we want. And it's very highly cost effective, and as well as more workaholic things are involved in this microelectromechanical system fabrication. And also this involves with the manufacturing, mechanical manufacturing and metallurgy and chemical technology, material science, electrical engineering, and many things. That's why it's an interdisciplinary nature of the work. Next, so majorly I will focus on the semiconductor device fabrication. And semiconductors are majorly involved for the materials, and not only semiconductors, and some plastics, polymers, ceramics, ferroelectric and magnetic materials, and especially bioelectric materials also very much useful for these devices. That's why biosensors and all biochips and all very popular these days. And MEMS-based devices, majorly it is used for sensors, actuators, accelerometers, switches, transistors, even what we are using the smartphones, that is also we have inbuilt with these devices, cameras, and everything is inbuilt in the small miniaturized MEMS-based devices, and also optoelectronic device also. The MOEMS, that is micro optoelectromechanical system sensors also very important. And these MEMS-based components is majorly the size of the range of the millionth of meter. That means a micrometer to a millimeter, thousands of the meter. So it's a micro electromechanical devices are available. And in normally this MEMS is called, generally called in USA. When we also we call as MST. MST means it's a microsystem.
Sir, your voice
But
is
everything
breaking.
is micro. Oh, okay, man. So I'm out of session, and I'm talking. So whether it is clear, ma'am, now?
Hello.
Ma'am, is audible?
Sir, little bit disturbance is there, but you please continue. Continue.
Yeah, yes. Because I'm on session, so I'm sitting outside office and outside home. Okay.
Okay.
Okay, I will continue. And these things and all we have to focus on this one. So majorly sensors, actuators, accelerometers, transistors, piezoelectric graphite, nanotechnology, surface micromachining, isotopic etching, anisotropic etching. These kind of indicators and all majorly involved for this bulk micromachining to micromachining. And the very oldest technique is LIGA process. LIGA means it's nothing but the German based name actually. It's X-ray lithography, electroplating, and molding. That is called as a LIGA process for fabricating the microelectromechanical system. And also screen, that is another process. That process, the Cornell University, they developed in 1992. There is a bulk micrometering process. Screen means it's nothing but the single crystal reactive ion etching and metallization of these kind of things. And also when we go for the NEMS, the nano electromechanical systems. So the application for the growth is, I think, it's endless actually. When we go for that, this range, accepted range for the size, we may know that below 100 micrometer. So below 100 micrometer to the nanometers. So up to 10 nanometer to some micron. So we may call it microsystems. Then we go beyond 10 nanometer or 15 nanometer. So we may go for the MEMS devices. So we can go up to the atoms. We can play. And in this case, I think we need more sophisticated tools are important and necessary because we have to keenly focus on the defects and the micromachining things and nanomachining. So we have to go for the sophisticated instruments for the nanostructures or molecules or DNA or atoms. And we can also find out the virus and whatever things. So if we deal with it's a very sensitive thing. So sensor means it's nothing we can measure the information. Else, means in the case of surrounding the environment, what or what we are going. Sensitivity is very, very important. And also the sensitivity is mainly depends on the frequency response or whatever. But also the in order to any sensor sensors are available from force, pressure, velocity, acceleration, and many more things. And also thermal systems, entropy, heat, thermal flow, heat flow, these kind of things. Chemical sensor means it's a concentration, composition, and reaction, and things. This is mostly kind of stuffs in chemical related analysis. And also the radiant, magnetic, electrical, these kind of sensors also more widely useful. So the material shades, when we go for the carbon, diamond, and these kind of things, it's very widely used for the electromechanical material and low cost, Typically, it's inverter and also the rate, and it is very well known for many. Everybody knows that it is very, very popular, and then the carbon nanotube based on it's very widely used for many environmental related or pollution related or health related problems that we can solve by using the carbon nanotube or carbon nanotube related sensor. So these kind of things are very popular for this kind of carbon based MEMS also very in the fabrication point of view, I think next slide. Next slide. Okay, let's go for the side. The etching process is very important for, ion beam, focus ion beam etching, reactive ion etching, and the screen printing technique. This kind of very old technique only, and ion beam, the reactive ion etching and wet etching. This kind of process very tedious, and wet etching is very simple technique, and also FID and RIE is a very expensive one, and also RIE is nothing but the oxygen plasma etching. So then only we can make it a device structure by using the V-groove technique and other things and so on. So we have to drill, and we can modify up to the micron to nano level. So we can go for some connectivity or interconnection or device interconnect. We can able to connect very easily. Okay, next one. And also for these kind of devices, so we will go for the photoresist. Photoresist are very, very photoresist, the positive and negative. So
Sir, your voice is breaking.
we expect. Oh, okay, madam. Mobile connectivity.
No, I am not
Okay,
able to
ma'am.
understand.
Oh, okay.
You just please change your connection or some switch the connection if possible.
Actually, if I'm on phone, I can do
Intermittently
that.
it is breaking. You please you continue. पार्टिसिपेंट आपको भी ऐसे
Sorry,
ही
madam.
ब्रेकेज आ रहा है कि मेरे तरफ से कुछ प्रॉब्लम है अदर पार्टिसिपेंट्स
Yes, ma'am. We also
Voice चा problem
Yeah,
ओके ओके
Voice is breaking.
I'm actually in the very out of station actually. So please forgive me because of the mobile
यस
connectivity.
कंटिन्यू
Yeah. Anyway, I will just skip very fastly. So photoresist, I think positive photoresist and negative photoresist both are having different applications. With the negative photoresist, the UV when we exposed by UV, then the pattern will be the distortion will be there. Okay, please, ma'am. And next slide now. So by using this photolithography, and so we have to develop the photoresist, positive and negative photoresist. According to the photoresist, the pyrolysis process. The pyrolysis process, what is the pyrolysis process means? It's a thermal composition of materials that is elevated temperature through the inert atmosphere. So then we can we can get a photoresist form by changing the chemical composition. The photoresist are patterned accordingly by using the vacuum environment or with some inert gas. So we can able to generate the patterns by using the formulas or by using the photolithography, photolithography by illuminating the light radiation. So we can create the 2D, 3D nanostructures, microstructures, and so on. So like this, so we have to coat spin coating technique we usually follow. And also, if we are going to use X-ray or UV, so we can pattern like that, and we can develop using the polymer photoresist accordingly. So likewise, we can pattern it and then make the sheet resistance. So when we go for the large area wafers, for example, 6-inch or for example 8-inch or 12-inch or 16-inch silicon wafers, when we go for the mass fabrication, so we may consider about the sheet resistance according to the unit area. So the sheet resistance is very important. So we have to consider the sheet resistance. If the sheet resistance is very high, then the device will be malfunctioned. So we have to consider according to the temperature versus the heat resistance. And also we need to consider the polymers, which polymer we want to use. And these things and all we have to consider. Next slide, ma'am. Next, okay. So and also we have to go through the high aspect ratio. The high aspect ratio. So how we are going to develop the process and how we are going to consider the new, smart packaging for the small micro batteries. When we use some micro batteries, so we have to get the micro batteries, and from the micro batteries, so we have to consider the power and voltage. So we have to create the patterns accordingly by using charges. So it depends on the chemical, which chemical, electrochemical. So we have porous material or some simple crystal materials, or we can create many pores orderly or disorderly, whatever it may be. So these kind of things. So we have to maintain the high aspect ratio. And then we have to finally generate the carbon electromechanical system technology by using this material and manufacturing solution by using this battery optimization. So we have to optimize the battery miniaturization problem accordingly. Next slide, ma'am. So likewise, we have to overcome the size and energy and the density deficiencies by through the 2D or 3D pattern. So in this kind of arrays, we can able to generate by using the carbon MEMS structure. So next slide. So accordingly, we have to find out the high current density on the small, small device or on silicon or whatever it may be, and also so we can connect the device structures, and we can create the CMOS integration, and also high repeatability of the device by using the batch process, and also the carbon based MEMS material is very widely useful for many applications. In these applications, I think we can make it efficient IC packages. Also, we can able to consider. And also we can interconnect this metal into this device, so we can get many other sensor related structures we can able to create. Next slide. And also the service to volume ratio also very important. When we consider about the smaller size, for example, if it is a 2 centimeter cube, the surface area of the centimeter is 24 centimeter, means that is volume will be about 8 centimeter cube. So the ratio will be 3:1, like when we go for the smaller structure. The bigger structure actually, if it is a 10 centimeter cube, so if you have a surface area 600 centimeters square, the volume is very big. So when we go for the ratio, it is 0.6:1. So the ratio wise, if we consider the ratio, the smaller objects are very attractive, and also it has a much greater surface area to volume ratio, then it will go for the nanotechnology applications. Next slide. So accordingly, we have to go slowly move from micro to nanostructures, and also these are all the some device structures patterned very nicely, and also like the pillars. So there are different orders, several orders we can able to make, several metals also we can able to connect accordingly. Like the pillars, half of the metal is nickel, or half of the metal is copper, or whatever it may be. So depends on the interconnection of the metals also we can able to create according to the very structure. So we can able to make some different kind of structures. Next. And also we can different levels we can able to create: first level, second level, third level. Different metals we can able to create, and one minute. So in chat box, voice is breaking. So likewise, we have to create many orderly structures, and also some suspended structures because of some defective structures. We have to control effect pyrolysis technique or spray direction. So we have to control the pyrolysis technique to optimize the device application accordingly. And also microchips also available. So the self-assembled structures also shown here, and also from MEMS to NEMS. So the photoresist as a carbon source, and also when we go for the gold film. So and if you put the island structure, so then we will create the photoresist degassing by using the gassing and using the local CVD technique. So we can able to handle the carbon nanofibers. So then the carbon nanofibers by using CVD process and many other techniques also possible to create the carbon nanofibers. Next slide. These are all the pictures for the nano slide. So these are all the 10 nanometer carbon. This one by analyzing the TEM image, transmission electron microscopy analysis. These are all the nickel nanowire is shown here. So from NEMS to NEMS, we can able to fabricate by using various methods. One of the method is CVD. The other method is vapor liquid solid methods, solid liquids solid methods. These technique are very popular for fabricating the MEMS devices. And also these are the energy spectra. Next slide. This is the TEM image shows the nickel nanostructure. Next slide. And now next slide. These are all the energy dispersive spectra for the composition analysis with different areas, what are all the chemical compositions are available, whether it is nickel, copper, and these kind of materials are present in this particular area or particular interface. We can able to method what are all the pillars are available, what are all the silicon nanowires are available. So these are all found by energy dispersive X-ray analysis by analyzing different various regions, we can be able to categorize. So like this, we can confirm what kind of metals we are fabricated, what kind of pillars we are fabricated. So we can be able to analyze like this technique, energy dispersive technique. Next slide. And also some forming gas at room temperature. Surface, how the surface is degraded, maybe sometimes very poor. The next slide. These are all the disorientation. It's not a good picture. It's not disordered one. It's not a correct pillar. So these are all the defects by using the mechanism. So by using the VLS technique or SLS technique. Now, next slide. So I will tell about a little bit about what is VLS technique. VLS is nothing but wafer to liquid, wafer liquid solid mechanism. So from vapor we are going to make a liquid and then pillars like a solid. So this is a image. It's focusing on liquid metal cluster or catalyst. It acts as the energetically favored site and absorption of the gas phase with the absorption, then again it will be go to the solid. So this is called the VLS method. With this technique, we are creating the nanostructures or nanopillars. Now next slide. And also the SLS method also. It's another method. So this SLS method we can able to by using the laser sintering or selective laser sintering. So we can fabricate the nanostructures by adding some additive manufacturing technique. Then we can able to get the nanostructures by using 2-dimensional or 3-dimensional model. So we can fabricate from NEMS to nanostructures. We can able to SLF mechanism. So we can fabricate some attractive nanostructures. Next slide. So these are the NEMS to NEMS in a normal pattern IC fabrication pattern structure. So on the silicon substrate, the nickel thin film is the first on the silicon 111 structure. So after that, the formation of silicon nickel azotic liquid droplets by using some wet etching or dry etching technique. So we make as a droplet, and then after that droplet and the continuous diffusion of silicon atoms will be growing through the substrate to liquid interface, and then the pillar is growing some orientation, some one direction or some orientation. The pillar is growing by using the SLS mechanism. Finally, the silicon nanowire growth will be possible for this direction. So like this, the nanopillars is next slide. So
Yes,
these
sir.
are
It's 10 minutes over. Kindly sum up.
It's finishing actually. Okay, these are the pictures that demonstrates CVD technique and during the pyrolysis technique. The next one, and it may be useful for many applications. I mean, for example, in the automotive, I mean, electronics, medical, communication, defense, and many applications are microelectromechanical systems to nanomechanical systems. There are, for example, the automotive devices. There are inertial or internal, some navigation sensors, air conditioning sensors, brake force sensors, suspension sensors, accelerometers, fuel level indications, airbag sensors, intelligence sensors. Likewise, in the automobile, many MEMS or NEMS is widely applicable. And also electronic devices, there are disk-based or inject printer heads, this kind of sensors, EarthCAT sensors, avionics sensors. So these kind of sensors are popular in electronic and medical. If you go for medical, blood pressure sensor, and also pacemakers, prosthetics, and implanted pressure sensors, film sensors. So these kind of things we can able to, it's possible for the miniaturized medical related sensors. And if you go for communication, fiber optic communications, fiber optic sensors, RF relays, and these kind of things are available. So finally, I will conclude. So just I highlight the understanding about NEMS to NEMS technology, and what are the fabrication, simple fabrication techniques, and what are the photoresist and developing, and CVD, VLS, SLS mechanisms are involved in this fabrication technology, and how the high aspect ratio is improved for the device structure, and also so there are some 2D or 3D MEMS structures or carbon-based structures are how it is popular, and also it was discussed, and also graphite or carbon-based nanofibers are very widely used for many applications. These are all things I would like to conclude. Thank you, madam.
Thank you so much, sir. Is it your research work, sir, or any other study?
Yeah, earlier 10 years before I did, ma'am. I see after coming to India, everything. I mean, everything I lost.
Okay,
So I
okay,
think
okay.
12 years, almost 12 years completed here in India. So
Okay.
before that, completely more than 7-8 years, I was in IC Fab.
Okay,
This is
okay.
I designed
Great,
and
great.
fabricated. Yes,
Nice
and
work,
many works.
actually. Yes, thank you,
After
sir.
coming to India, we could not able to do actually.
Okay.
Only teaching to the college
Yeah.
students, PG
Okay.
and PG.
Have you published
No.
paper on this? Have you published paper on this
Yeah,
stuff?
yes, many.
Yes,
Yeah, if you
many
if you
papers.
type it,
Yes,
if you
because
type
it
my
is
name,
very
everything comes.
appreciating work. Very nice work.
Yeah, if you type my name, everything will come actually.
Yes. Okay.
Yes.
Thank you so much, sir. Thank you.
Thank you, ma'am. Thank you.
So, friends, here we have finished all the presentations of all the participants. Are you all there?
Yes,
Yeah.
madam.
Yes, ma'am.
Yeah.
Yes, madam.
So now we have finished all the seminars. We are at the end of our refresher course rather. कल का अपना आखिरी दिन है. अभी देखिए मूडल के जो 2 टॉपिक्स है वो मैंने वीडियो के फॉर्म में ऑलरेडी मेंशन्ड है अपने यहाँ पे. हाउ टू गिव क्विज इन एज अ एक्टिविटी एंड हाउ टू एनरोल स्टूडेंट्स. लास्ट 2 वीडियोस यू जस्ट चेक. लास्ट 2 वीडियो में आपको ये 2 चीज़ें मिल जाएगी. हाउ टू एनरोल स्टूडेंट्स एंड हाउ टू गिव क्विज एज एन एक्टिविटी. So that part you can do on your own. And for tomorrow there are few instructions. Please listen properly. Tomorrow we are having one session in the morning, that is at 10:30 to 12 o'clock will be our first session of Dr. Hirwade madam, that on PBS and API. After 12 o'clock in continuation you will be having your examination, online examination, 30 questions, 30 marks, 30 minutes. ठीक है, तो आधे घंटे की एग्जाम रहेगी आपकी. टिल 12:30 यू हैव टू गिव इन द लाइव फॉर्म. आप लोग मीटिंग में ज्वाइंट ही रहेंगे. दूसरे नए टैब में आप मूडल साइट ओपन करेंगे एंड देयर यू हैव टू सॉल्व योर फाइनल एग्जामिनेशन, सो दैट आई विल बी देयर विथ यू. इफ यू फेस एनी टेक्निकल डिफिकल्टी while solving that particular exam, so I will solve your problem. And followed by that, tomorrow there will be 2 Google form. One is related to feedback form of our refresher course and another one is related to postal address for your certificate distribution. Everyone has to fill that particular Google form. There will be 3 questions. Your name, can you come to HRDC Nagpur office to collect the certificate, yes or no वाला option है वहाँ पे. If no, then third question, kindly give your postal address. तो सभी पार्टिसिपेंट्स को वो गूगल फॉर्म भरना है. इट विल बी डिस्प्लेड टुमारो. एंड जो लोग नहीं आ सकते हैं वो लोग अपना पोस्टल एड्रेस थोड़ा सा बराबर डालिए. प्रेफरेबली होम एड्रेस दीजिए, क्योंकि प्रीवियस बैचेस में ऐसे देखा गया है कि आप लोग कॉलेज का डिपार्टमेंट का एड्रेस देते हैं और वो सर्टिफिकेट मिसप्लेस हो जाता है. सो प्रेफरेबली आप अगर होम एड्रेस दे सकते हैं तो प्रॉपरली स्पीड पोस्ट से वो आपके घर तक पहुंचेगा सर्टिफिकेट. और जो लोग आ सकते हैं दे कैन कलेक्ट इट फ्रॉम Nagpur HRDC office. So these are the few instructions regarding tomorrow's session. You will be free by 1:30 or by 1:30 tomorrow. So if you have any question or any query, you feel free to ask. उद्याचे टायमिंग्स कळले आहे. टायमिंग येस.
रिलीविंग लेटर केव्हा मिळेल?
रिलीविंग लेटर आपको मेल के थ्रू आएगा, नॉट इंडिविजुअल रिलीविंग लेटर. There will be 2 files in your mail attached. One is a duly signed relieving letter by director of UGC HRDC Nagpur, but there the name is mentioned as per attached list. Such wordings will be there. And side by side there is one PDF final selection list of all of you. सो आप जो कॉलेज में सबमिट करेंगे वो 2 फाइल सबमिट करेंगे प्रिंट आउट निकाल के. रिलीविंग लेटर जो सर का साइन हुआ रहेगा, अलॉन्ग विद दैट पीडीएफ फाइल जो हम लोग भेजेंगे, वो 2 चीज़ें आपको कॉलेज में सबमिट करनी है. तो वो कल आफ्टरनून या तो
लिस्ट भी साइन किया हुआ होगा
यस
HRDC
अभी देखिए टुमारो इज 4th सैटरडे, तो मे बी बाय मंडे मॉर्निंग यू विल गेट द मेल.
Okay.
So because our is a government holiday tomorrow, so director will not be available. So maybe by Monday morning you will get the mail, क्योंकि अभी आप लोग ज्वाइन तो मंडे को करेंगे ना कॉलेज, तो मंडे हो सके तो कल ही मिल जाएगा. इफ नॉट यू विल रिसीव इट बाय मंडे मॉर्निंग बाय 11 o'clock. ओके
मॅडम सर्टिफिकेट फ्रॉम डिपार्टमेंट केव्हा मिळेल?
हाँ, दैट आई विल इन्फॉर्म यू इन अवर व्हाट्सएप ग्रुप, बिकॉज कल जैसे ही ये खत्म होता है इसके बाद आप लोगों का पूरा इवैल्यूएशन होगा, मार्कशीट बनेगी. सर्टिफिकेट आपने जो करेक्शंस किए हैं उस हिसाब से सर्टिफिकेट प्रिंटिंग होगा, मेरी साइन, डायरेक्टर सर, वाइस चांसलर, तीनों की साइन होगी. इट टेक नियर अबाउट 3 to 4 days more. And afterwards, I will send message in our WhatsApp group. Then only you can come.
Okay.
And timing second, fourth Saturday off असतं HRDC ला and regular timing 10:30 to 5:30.
Okay. Thank you.
Any more
Okay.
question?
मैडम ये जो एग्जाम होने वाली है वो एग्जाम ये पूरे जितने भी
हा
लेक्चर्स है
आजपर्यंत
उसके
जेवढे आपले आता उद्या पीबीएस वाला टॉपिक आहे त्याच्याशी रिलेटेड नाही राहणार तुमचे क्वेश्चंस. अभी तक जितना भी हुआ है कवर इंक्लूडिंग माय सेशंस ऑफ प्री रिकॉर्डेड वीडियोस प्लस जो भी अपने लाइव सेशंस हुए सिंपल क्वेश्चंस रहतील. सबको अच्छे मार्क्स आएंगे. आई एम वेरी मच श्योर अबाउट इट. जो ऑलरेडी क्विज आप लोगों ने दे भी दिए हैं वो भी रहेंगे, मतलब रिपीटेशन भी रहेगा क्वेश्चंस का. ठीक है.
आणि आजचं हे सबमिशनच राहील ना रे
रिपोर्ट सबमिशन एकाच सेशन वरती जे आपलं सकाळी झालं, बाकी तर आपले सेमिनार्सच होते.
हं.
ठीक आहे. और किसी को
मॅडम
कुछ क्वे-
मॅडम मूडल साईट तयार झाल्यानंतर त्याचं इव्हॉल्युशन किंवा सबमिशन ऍज काही करायचं नाही ना?
मॅडम दिलंय ना मी सबमिशन ऑफ मूडल साईट, त्यावरती आपल्याला मार्क्स आहेत. बघा 4-5 दिवसांपूर्वीच मी ठेवली. जिथे मूडल साईटचे व्हिडिओज आहे ना त्याच दिवशी
हो.
किंवा त्याच्या 2 दिवसानंतर बघाल असेल एक असाइनमेंट आहे सबमिशन ऑफ मूडल साईट.
हो ते तर नाव तर दिलं होतं मॅडम साईटचं.
तर तुम्ही जे डे बाय डे अपडेट करताय आहे ना मॅडम ते ऑटोमॅटिकली
हा, ते
वेब वरती अपडेट होत आहे. तर मला मी जेव्हा चेक करील तेव्हा मला अपडेटेड वालीच तुमची हे दिसेल जर केलं
ओके
असेल तर.
ओके मॅडम.
हम्म.
हो केलेलं आहे मॅडम.
हा
चालेल.
तर ते सगळं मला लॉग इन ॲज अ गेस्टच्या थ्रू जेव्हा मी जाईल ना तर तेव्हा तुम्ही जे
बरं.
जे स्टेप्स परफॉर्म केल्या असतील त्या मला दिसतील तिथे.
ओके मॅडम चालेल.
30 क्वेश्चन आणि 30 क्वेश्चन असतील ना फक्त
हा
30च आहेत ना?
30 क्वेश्चन 30 मार्क्स 30 मिनिट्स.
30 क्वेश्चन 30 मार्क्स 30 मिनिट्स ठीक है
हाँ।
मैडम ऑनलाइन असते मागे
ऑनलाइन
जसे दिले तसे
यस जैसे अभी आपने इसके पहले क्विज दिए ना ये सारा मॉडल
हाँ।
के ऊपर सेम पैरेलल लाइन पे कल के डेट में आपको फाइनल एग्जाम दिखेगी.
ठीक आहे मॅडम.
मॅडम ते काही ठराविक वेळेमध्येच सॉल्व्ह करायचे का की
हाँ, 12 बजे अपना सेशन हो जाएगा ना हिरवड़े मैडम का.
हाँ, हाँ।
उसके बाद में उसको शुरू करूंगी तो 12:30 पौन बजे तक वो शुरू रहेगी.
अच्छा अच्छा मतलब 1 से 12 से 1 के बीच में वो
हाँ।
लाइव रहेगी.
12 से 12:30 मतलब 30 मिनट्स की एग्जाम है. आपको एट ए टाइम सबको शुरू करनी है. आई विल बी देयर इन द लाइव सेशन. आप सभी लोग
Okay.
लाइव सेशन में जुड़े हुए रहेंगे और साइमल्टेनियसली अपने कंप्यूटर पे या तो मोबाइल पे आप एग्जाम सॉल्व कर रहे होंगे. ठीक है.
जी,
मतलब मेरे पास सबके ग्रेड्स आ जाएंगे. आई विल शो यू द ग्रेड्स एंड देन ओनली आई विल गेट कंफर्मेशन कि सब लोग पास हो गए हैं. उसके बाद ही अपना वोट ऑफ थैंक्स होगा, मतलब वैलिडिटी होगा. अगर किसी
जी.
का कुछ कनेक्टिविटी के इशू के वजह से नहीं हुआ है तो वो भी प्रॉब्लम हम सॉल्व कर लेंगे वही के वही.
जी मैडम
ठीक है.
थैंक यू.
मैम टेस्ट 12 बजे चालू हो जाए.
हाँ जैसे ही मैडम का सेशन हो जाता है आई विल स्टार्ट. तो आप मोबाइल से भी सॉल्व कर सकते हैं या तो लैपटॉप से भी सॉल्व कर सकते
Hello,
हैं. यस सर.
ma'am. Excuse me, ma'am. In the selection list, my name has one unwanted space in between of spellings.
Sir, have you not mentioned that in the corrections? Ajay Kumbhare sir sent us a list in our WhatsApp group for corrections. So there
Yeah.
have you not mentioned
No,
which
madam,
corrections
but-
you want?
But I mentioned through mail, no.
No, not in the mail. I am talking about WhatsApp group. Many participants had made lot of corrections.
Yeah, I sent WhatsApp message to you.
Not personal, I am talking about WhatsApp group. जो अपना ग्रुप बना है रिफ्रेशर कोर्स का. In that group, our HRDC officials are also there in our WhatsApp group. जो सर्टिफिकेट्स रेडी कर रहे हैं.
मैडम ये इनको
I
आपने अभी
think I
2 दिन
sent
पहले
message to
ज्वाइन
you. I
करवाया
think
था.
in our group,
नहीं
ma'am.
पहले ये थे ग्रुप में सर, बीच में लेफ्ट हो गए थे. Initially he was there in the group.
Oh,
Yes.
but I sent message, ma'am.
You just once send
Yeah.
another message in the WhatsApp group. Let's see
Yeah.
what will happen. That
Okay.
Kumbhare sir make all the changes.
Oh, okay, ma'am.
Okay.
Okay, thank you.
So fine, here we will stop our meeting. All the best for your tomorrow's final exam. Just एक बार go through कर लीजिए सारे PPTs या तो सारे videos एक बार, या तो आपने रनिंग नोट्स निकाले होंगे हर सेशन के, या तो रिपोर्ट सबमिशन करते वक्त आपने कुछ डॉक्यूमेंट्स रखे होंगे अपने पास, तो एक बार उसको गो थ्रू करिए, अच्छे से एग्जाम दीजिए. एंड थैंक यू ऑल ऑफ यू फॉर योर काइंड कोऑपरेशन थ्रू आउट द refresher course. Thank you so much. See you tomorrow at
Thank you.
10:15.
Thank you, ma'am.
Yeah, our session will start at 10:30. Tomorrow our session will start at 10:30 instead of 11 o'clock.
Yes, ma'am. Thank
Okay?
you.
चलिए.
Yes, ma'am.
Thank you all of you.
Okay, ma'am.
Thank
Okay.
you.
Thank you,
Thank
ma'am.
you. Thank you, ma'am.
Thank you, madam.
Yes.